Ladies, today we are going to start chapter 3, graphs of equations. So during this chapter you will be able to plot and interpret distance time graph and velocity time graph. We will deduce from the shape of distance time graph when a body is at rest, when it's moving with uniform velocity, when it's moving with non-uniform velocity. So from the shape of distance time graph, we will be able to know if the body is moving with constant speed, if it's moving with changing speed, or if it's not moving at all. From the shape, you will see later how. And from also this distance time graph, we will be able to find the value of speed. Okay, we can find the value of average speed or instantaneous speed. Also, you will see later how. The third and the very important objective for this lesson is to deduce from the shape of velocity time graph when a body is at rest, moving with uniform velocity or uniform acceleration. So from the second type of a graph, which is velocity time graph, also we are going to see how we can know if the object at rest or moving with uniform velocity or uniform acceleration. So today we'll talk about 1 and 2. Okay. So first of all, let's talk a little bit about graphs. What are graphs and what are the important points you should pay attention on in IGCSE. So graphs are useful for sure to finding relationship between two quantities. So as you know, for the graph, always you have the x-axis and you have the y-axis. So when I plot a graph, I'm finding a relationship between y and x. Choose scales that make it easy to plot the points. So when we solve, you will see that we should find a scale, okay, that match with our numbers, okay. So you will see later during the problems how to find the best scale. Okay, so first we are going to find a scale, and usually, girls, we use as much as we can from the graph paper. So in paper 6, there is a graph paper given for you to draw on it. Okay, so we don't use only small part of it. We use as much as we can from this graph paper. Why? To make our graph more clear and neat. Okay, so we use as much as we can from this paper, at least more than 50% of the graph paper. Make sure you label each axis. So in order to take marks in paper 6 for drawing graph, you should make sure that you label each axis. So if I'm talking about distance time graph, you should label the x-axis time, okay, per second. You should put the unit, and the y-axis you should name it distance, okay, and you should also put the unit, which is per centi or meter, depends on the question or the givens you have. Okay, so if you label only the axis, you will take mark. Okay, so you will label the axis with the name and with the name of the quantity and the unit of the quantity. Mark the data clearly with a dot in a circle or a cross. So with a sharp pencil. So when you draw and you have different points, you have to place them in the graph. The points should be placed like this, like X if you want to mark, and the pencil should be very thin, very sharp in order to avoid the inaccuracy, which is due to the thickness of pencil. Okay, so you will see all the placements later when we solve in paper 6. But now I'm telling you about the important notes in graphs. Join up your points with a smooth line or curve. Okay, so when you join the point together, you should join them also with a smooth line, not a thick line. Okay, and also you'll see later for sure, we try always to join as much as we can points, but if there is a point on a side, we keep it on a side and we don't join it with our line. Okay, so these are the points that are important in graph, and they put on them marks in past papers in the external. Okay, so you for sure we are going to go through them later when we solve paper 6 questions. Also, in paper 6 questions, you are going to have question if the graph they ask you, is this graph linear or like a graph or not? Okay, so when the line passes through most of the dots, most of the points you have, the graph is a linear graph. Okay? But when this line passes most of the dots plus it starts from zero, so here we say that these two quantities, if I have, let's say, distance here and time, x and y, whatever, x and y, we say that x and y are directly proportional. So this graph is directly proportional. Okay? So when you have only a straight line that passes through most of the dots, most of the points you have, the graph is called linear. But when the line passes through most of the dots plus it passes through zero, okay, through the origin of the graph, we call it the directly proportional graph. Also, we will see it later in past paper 6 questions. Now we will start our lesson. I will start with you first about distance time graph. Okay, in the book, they start with velocity time graph, but I will start with you with distance time graph so you can find it in not the first page of the chapter, in the second page of the chapter. Hi girls, so you have distance time graph. What do you expect? Where will we put the distance, on y-axis or x-axis? So no, for sure we will put it on y-axis. Distance is on y-axis because it's called dependent variable. Okay, at the time always girls is on the x-axis. Time is look, time is called an independent variable. Do you know what means independent? From its name, independent variable, it means girls, like this time it doesn't depend on anything. Like if now the car moves or not, the time will pass. If I give you a physics lesson or not, the time will pass. Okay, so the time it doesn't depend on others, okay, but others depend on it. So that's why always when you have like time, a quantity, the time will be plotted on x-axis, because on x-axis we put the independent variable. Okay, and on the y-axis we put the dependent variable. So the distance depends on time, but time doesn't depend on anything. Okay, so time is the independent variable and it's always placed or plotted where? On the x-axis. So the first step, girls, is to draw the lines, okay, to draw x-axis and y-axis, to label x-axis with time and to put the unit, to label y-axis with distance and to put the unit. If you do only this step in paper 6, you are going to take 1 mark. Okay? In drawing a graph. So only label the axis plus units, you will take 1 mark. After that, you will draw. Let's say that our graph now is ready and I want to analyze it. Okay, the graph is ready here, but I want to analyze it. I want to check how is my car moving. Okay, is it moving like like at constant speed? Is it moving with increasing speed? Is it accelerating? Is it decelerating? Okay, so when you look at the graph, you will be able to get some information. Okay, girls. So the y-axis represents distance, x-axis represents time. Look at the first part of the graph. Okay, look at this part. During this part, they said that the car is traveling at constant speed. Why? Girls, like just repeat the meaning of speed in your mind. Now, the speed is distance over time. Speed is distance over time. So I will write it here, is distance over time. Okay, so if the car is covering equal distances in equal amount of time, so the car is not changing speed, is moving smoothly with the same speed. Exactly like here. Check here, see. During the 2 seconds, the first 2 seconds, the car moves 2 meters. Okay? طيب, during also here, from 2 to 4, during the second interval of time, here, the car moved, look, from here to here. So from 2 to 4. Okay? طيب, during the here also the third 2 seconds, this interval of time, the car also moves from 4 to 6. So the car is covering here equal distances in equal interval of time. Equal distances in equal interval of time. So we say that the car here is moving at a constant speed. Okay, so this is the first rule. When the graph is straight here, okay, it's straight. So when the graph, which graph? We are talking about distance time graph. Distance time graph. When the graph is straight, so the object is moving at a constant speed. Okay, the object is moving at a constant speed. Type, what do you expect here? Girls, think about it before I show you the answer. Here, straight but what? Horizontal. Straight but flat. So this part of the trip, let's say, this part of the trip is straight but what? But flat. Not sloped like this one. Okay? So this is a flat part, this is a horizontal part. Okay, let's check. So during here from 10 seconds to 12 seconds, what happened to our car? Let's check, girls. So see, the distance traveled by the car was 10, and the car stopped here at 10. Like during this interval of time, during these 2 seconds from 10 to 12, during these 2 seconds, the car doesn't like cover more distance. It's like it stays at 10 kilo. Okay, it was at 10 kilo here, so it stands or it stays at 10 kilo in its place. So during these 2 seconds, from 10 seconds to 12 seconds, the part of the graph was flat, was horizontal, so the car was what? Here at rest. It's not moving. Okay, the graph is not going up, it's not sloping upward. It just here the slope of the graph is 0. I'll tell you about the slope later, what I mean by it. So look, you can check from y-axis, the car stays at 10 kilometers and it doesn't cover more distance. So during this part, what do we say? The car here stationary or at rest. So until now we have two rules. Okay, when the graph, it's straight like this one. Okay, the car is moving with constant speed. When it's flat, horizontal, the speed is 0. The car is not moving anymore. When here again, so again, what do you expect, girls? So again, here the distance increases. Look, the distance increases with time. The distance increases with time. So the car now is covering more distance with time. So again, here there is a speed, and the speed is constant since the graph is straight. Okay, so speed is distance over time. Okay, girls, how to find now the value of speed from the graph we have? Very easy, but we should for sure practice. Speed, put the equation speed is over time. Let me choose 2 points on the graph, on the straight part. So this is the first part of the trip of the car. Let's say this is the second part of the trip, and this is the third part of the trip. Okay? So during the first part, we said that the car is moving at constant speed. Okay, like what is the value of this speed? What is the magnitude of this speed? So choose 2 points on the graph. Let me choose, let's say, this point, okay, and this point. Okay, girls. So I chose this one and this one. Okay, distance over time. Tell me, girls, what is the distance covered during these 2 points? From this point, let's say point A, and here point B. Look, at point A, the car was at 2 kilometers. Type at point B, the car is now at 10 kilometers. So what is the distance covered during this trip from A to B? From 2 to 10, From 2 to 10, you can just say what? 10 minus 2. 10 minus 2. Okay? So the distance covered is here 10 minus 2, so it is 8. Okay, what about the time? So speed is equal to distance over time. Let's check, girls. At point A, the time was 2 seconds, the time on our stopwatch. Let's say at point B, in the trip, the time was 10 seconds. Type. So what is the time taken for this trip from A to B? What is the time taken? It is from 2 to 10. Okay, so you can just say also 10 minus 2. Type. Another easier way is to what? So here it's 5 over 5. Okay, so not 5 over 5, sorry, it's 10 minus 8, 2, it's 8 over 8, and it will be 1 kilometer because the unit of distance kilometer, the unit of time here is hour, so 1 kilometer per hour. Yes, so here I will give you just the same way, but in another, the same method, but in another like a way of calculation. So we can just say now that when I choose here 2 points on this graph, I'm finding the slope of the graph here. Why? You remember what is a slope in math? Slope, if you remember, girls, it is, I'm show you here. Okay. Yes, slope, you can say it is rise over run. What is the rise? When you choose 2 points, the rise is this one. It is the vertical distance. Sorry, it's not that clear. So the rise, it is the vertical distance between these 2 points. So this one we call it rise, and this one we call it run. Run, it is what? The horizontal distance. The horizontal distance. So you can do it like this. Just rise over run. Okay, so rise, what is the rise? It's distance from here to here. From 2 to 10. From 2 to 10, it is 8, right? So 8, you can just do 10 minus 2, it's 8. So run, what is it also? From 2 to 10. From 2 to 10 or 10 minus 2, also it's 8. And you can find it 1 kilometer per hour. So as you can see, girls, here the speed, we found it first using the formula, the original formula, and we found it using the slope, and we found that the speed is equal to slope here of the straight part. So the speed of the car during this straight part is equal to what? Is equal to the slope of this straight line, Okay, girls? So you can find the slope in the way that you want. Let me give you another example. If someone choose another two, let's say another 2 points, okay? This point and this point. Type. So let's find the rise and run. So rise, it's the vertical distance between the 2 points. So this is the rise, and the run, it is the horizontal distance between the 2 points. So in order to find the rise, we just here look at the graph. You see these points, okay? You make dashed line here and dashed line here, and you find the rise. So slope is equal to rise over run. So rise is equal to here, let's find it together. So this point is what? It's 7. This point is what? It's 4. Type from 4 to 7, girls. 1, 2, 3. So 3. Okay. Let's check the run. What is it? The run, it is also here from 4 to 7. So 1, 2, 3. So also 3. So the slope here, it's also 1 kilometer per hour. So I chose, girls, 2 different points, but I found the same answer. Okay, so you can choose any 2 points and you will find the same answer. Okay, but if you use for sure the correct way of slope. So here I have this note for you. It's to help the girls who don't know how to find the slope or the gradient. So slope is called also gradient. It's the same meaning. So the slope or gradient of a straight line graph can be determined by triangle method. So this method is called a triangle. Gradient or slope is equal to change in y, which is the rise, over change in x, which is the run. Okay. Here you have an example. Okay, so girls, here you have 2 points on this straight line. The coordinates of these 2 points are given, 8, 6, and 2, 3. So in physics, they will not be given. You will find them. Okay, how to find them? Very easy. Just project here a horizontal line to the vertical to find this one, and project a vertical to this one and to find this one. Okay, so you use as long a length of line as possible to determine the gradient from the ratio of rise over run. What does this mean? So girls, to make it easier for you, don't choose 2 points that are very close to each other. When you use 2 points that are very close to each other, it will be hard for you to find the rise and run. Okay, so in order to make it easier to find the rise and run, use 2 points that are far from each other. I can choose this one, let's say A, and this one B. Okay, choose any 2 points on the straight line, but don't choose them very close to each other. Use them far from each other to find the rise and run in an easier way. Okay, so for sure, if you have any question or doubt, write it on a piece of paper so you can ask me about it later. So this is summary about the things we've already said. Okay, girls, so focus with me here, please. I'm sorry, what is this? Okay, so when an object is stationary, the line on the graph is what? Horizontal. So horizontal, flat, nothing. So see this one, girls. It's flat. Look, the object here stays at 8 meter, and doesn't move anymore. So it stays at 8 meters. So the object here is at rest. Okay, no motion, no speed. Speed is 0. What means at rest? No speed at all. Speed is equal to 0, stationary. Like when an object is moving at steady, so sometimes they use the word steady instead of constant, the same thing. So at a steady, constant speed in a straight line, the line on the graph is straight but sloped. So this is the straight. Look, girls, the purple and this green, this one, let me say 2, 1, and 2 here. Okay, both of them are what? Both of them are straight. Okay, but not flat, so straight and sloped. Okay, straight and sloped, not flat. So flat means 0 speed. So here 1 and 2, both of them are straight. And so girls, here in these two, the speed is constant. So a car 1 here is moving with constant speed, and car 2 also moving with constant speed. But there is a difference between them. Think about it a little bit. Okay, both of them are moving with constant speed. Which one is faster than the other? Car 1 or car 2? What do you think? What do you think, guys? Which line is steeper? Which one is more steep than the other? So this one, the purple one, right? The purple one is steeper. What does mean steeper? Steeper, it means that the distance covered by the object is increasing more rapidly. So more rapidly, girls, like if you check it, see, during here 1 second, look, during 1 second, okay, 1 second, the distance for car 2 increases by 2 meters, okay, but the distance for car 1 increases by 5 meters. So which car is covering more distance in the same time? Which car is covering or is moving more distance in the same time? So I will show it to you again using another color. Okay, so see, during the first second, the car 2, so here let's say car 2 here, and this is car 1. Car 2 moves, look, 2 meters, but car 1 covers, look, this point that intersects with my dashed line, 5 meters. So car 1 is covering more distance, okay, is moving more in the same time as car 2. Okay, so car 1 is faster. So the steeper the line, the more speed. The steeper the line, the faster the object is traveling. The purple line is steeper than the green line because the purple line represents an object which is moving more quickly, more rapidly. Hope it's clear. So we talked about this part. So this is stationary. And what about the one which is sloped downward? So girls, it is also straight. So here also the speed is what? Also it is constant. It's steady. It's constant. Okay? Since it's straight, so the speed also it's constant, but it's sloped downward. So here the car is returning, let's say, to its starting point. Returning to its starting point. Okay, returning in the opposite direction. So here the speed is if we are talking about speed, so only value, speed, it's a scalar quantity, it doesn't have any direction, so you will not put negative. Okay, if you are talking about speed. But if we are talking about velocity, so during this part, we can just put what? It's negative. Why? Because the negative sign here, it just shows the direction. So velocity, if you remember, it's what? It's speed and direction. Okay, but don't confuse yourself with this, like, because we will not talk about velocity a lot, we will find speed. Okay, so the slope or the gradient of a distance time graph, what does it represent? The velocity or the speed. So when you find now the slope of this, you are finding what? You are finding the speed during this part. When you find the slope of this, you are finding the speed during this part. Type here, when you find the slope here, do you have any slope? No slope here. It's not sloped. The part it's not sloped, it's flat. So slope is 0, speed is 0 during the flat part. Clear? During the flat part. Okay, girls. Um, so study this part very, very well. I will continue next time. Okay. So hope that everything is